Now in this video I'm going to show something that I learned a long time ago, back when the dinosaurs were basically walking upon the planet. And of course it's another obscure subject. And this is about measuring the capacitance of an electrolytic capacitor with a basic VOM. And I need three things for this. I need a stopwatch, I need my fluke multimeter or capacitance meter, which is of course integrated into the fluke multimeter, and I need the VOM. And what I'm going to do, I'm going to use the ohmmeter function of this, and once the capacitor charges, I'm going to read the needle. Once it hits a certain point, then I'm going to stop the stopwatch, and that's going to give me the capacitance reading. So basically, if it stopped after 10 seconds, then my capacitor should be 10 microfarads, for example. And this works with time constants. People remember that it takes like 5 time constants to charge a capacitor. And the first time constant is 63.2%. So, for example, if this would have a 1.5 volt battery in it, the ohmmeter, once the capacitor charged and it reached 63.2% of that 1.5 volts, that's the first time constant, and that's going to give us the reading of the capacitor. Hopefully I'm kind of making sense here. Let me go ahead and find the stopwatch first. I'll probably got to use my phone. So I managed to download myself a stopwatch app. What I'm going to do is I'm going to read off the ohm scale. And basically, I'm using the R times 100K scale because that's the only way I was ever able to do this and get a direct reading without doing any kind of math. So basically, once it reaches 17 right here, and I could use the volt scale up here. Of course, I don't have a 1.5 volt scale. I've only got 3 volts. But now 63% of 3 volts, well, I think that should be double what it'd be if it were 1.5 volts. If it were 1.5 volts, it would be 0.95 volts. 0.95 volts is 63.2% of 1.5 volt. So this will be double that, and this will be 1.9 volts, which would be right there. Or if I use the ohm scale, it would be down here at 17. So I think it's probably easier for me to read the voltmeter scale. Again, this is going to count once it reaches this point, or this 1.9 volts, or this 17 point. There's 10, 20, and there's 17. And again, I'm on the R times 100K. And then I should be able to take a direct reading, and that should be basically okay. Now, if it was, of course, 6 volts, then it would be 63.2% of 6 volts in order to reach that first time constant, and that would give us our reading. Now, kind of hope this makes sense here. So, starting out with a 220 ohm, 220 microfarad capacitor, and what I'm going to do now, I have to discharge this thing first, or of course we're going to get completely erroneous readings. And I want to observe polarity here. And as soon as I connect this thing, I'm going to go hit the stopwatch and then watch the needle. The needle's going to, pointer here is going to swing down to 0, and then it's going to come back up, and then once it charges at 1.9 volts here, or 17 on the ohmmeter scale, doesn't matter, then I'm going to hit the stop button here, and those seconds I read here, that is supposed to be the capacitance in microfarads of this capacitor. So start here, Well, I think what I have to do, I have to turn it on first, of course. Got to turn the ohm meter on. And not only that, but I got to get this out of the way. First thing has got to be zeroed out and ohmed out, of course, by just doing this. And then that was zeroed out. Now I ohm it out. Okay, now I'm finally ready. Of course, capacitor discharged. Now, of course, I started this. Shut that off. So again, all I do is connect, hit the stopwatch, watch a needle. In my case here, when it's reached 1.9, and then hit the stopwatch again, look at the seconds, and that's supposed to give me the capacitance. So I'm finally ready. I just noticed I had the wrong capacitor, of course. But I am going to use the wrong capacitor. This is a 100 microfarad capacitor, and again, it's completely discharged. Now I'm going to hook it up. I'm having problems here hooking this thing up, and once I hook this thing up, I'm going to go ahead and hit the stopwatch, and then once the needle reaches the 1.9 volt mark of the 3 volt scale, or 17 on the ohm scale, then I'm going to hit the stopwatch again, and that's supposed to give me my reading. So I'm ready. Now this is supposed to take exactly 100 seconds, so once I edit this thing, I'm going to go ahead and speed this portion up until it reaches right before 100. I may as well lay it down. So here we go, and this took 1 minute and 43 seconds, which is 1 minute, of course, is 60 seconds plus 43 seconds. So it read 103, which is right over 100 microfarads. So I would say this is a pretty close method, but let's go ahead and use the capacitance meter. Sometimes there are different variances here. It depends upon how fast you hit the stopwatches. Of course, that's going to make a difference too. So let's go ahead and make sure we're actually get this thing out of the way. We'll take a measurement of that, and it should be 100 microfarad, right? Of course, if its capacitor is completely open, or it's shorted, or if it's leaky now, it's not going to go, might not go all the way back up. So let me go ahead and take this reading. Basically, this test is to show you a ballpark value of a good capacitor. Because, you know, if it's leaking, the needle just might stay stuck or something. Or if it's shorted, I mean, and it's going to be shorted. Or if it's going to be open, it's not going to move at all. So, well, 97.7 volts. So it's kind of ballparkish. Okay, we'll try the 10 microfarad capacitor. I mean, you can try all different kinds, but of course, the larger they are, the longer it's going to take. Like a 1,000 microfarad capacitor might take a little bit, or you might have to change the ohms range here, but then you got to do some math. So again, 10 microfarad capacitor. We got everything set up here. Yep. So again, we got it discharged completely. Hooking it up now. And now charging. Oh, that was quick. So I read here about 10 seconds. That should be 10 microfarads. So we'll hook up this here. Again, this is not an exact science or anything. You just got to play around. You can play around with the ranges too. This was kind of like, I guess this was before the days of if you didn't have a capacitance meter or something like that, or some kind of a bridge circuit. Let's see what we get here. Not 10.1. Okay. So I've got one final test with the 47 microfarad capacitor, and I've got it discharged, which is important. You don't want this thing to be partially discharged because you're going to get a fake reading. Now when I do this test, I always observe polarity. And now I'm going to hit the stopwatch, and this should take 47 seconds. Supposedly. I think I'll have to speed this up there. So there we go. It was showing 50 microfarads, and it's actually 47. So it is kind of accurate. Anyways, I don't have anything else to add. You'd have to experiment around yourself if you were interested in this obscure topic. Thanks for watching.